Good afternoon, everyone. My name is Nirchar Bera, presently working at Netsim. So today I'll be demonstrating Netsim network simulator with a focus on cognitive radio and various features and functionalities this network simulator provides. So using Netsim, users can design, analyze performance, validate networks, and it also allows users to edit the network protocol. So why Netsim, or rather any network simulator? And the reason is very simple. With the advancement of technology, newer and newer protocols are being drafted, and it is really difficult to keep oneself updated with all the latest happenings. In addition, analyzing network behavior while using some traditional analytical methods has also become tough, and it is not easy to manually analyze the network behavior considering the fact the large number of parameters involved. Hence, Netsim is used to provide an accurate understanding of network behavior and the associated problems and respective solutions. So, Netsim is a scientific tool for designing, validating networks and protocols, and hence has a lot of relevance in protocol research and development. And in defense, for instance, is used for simulating network-centric warfare scenarios. The wide range of technologies possible to simulate in Netsim are internetworks, which is LAN, WAN, and wireless LAN, mobile ad hoc network, WiMAX, cellular networks, which contains GSM and CDMA, cognitive radio networks, LTE, and wireless sensor networks. In Netsim standard version, the users are provided with C source codes of the network protocols. And this C source code is implemented based on the IEEE and IETF standards. The purpose is to enable the users to edit the standard protocol code according to one's logic or implementation, link it with Netsim, and then analyze the performance of the newly designed protocol, and if required also compare with the standard protocol. So Netsim has a huge number of customers varying from industries where it is used for network design and validation to defense labs where it is used for network-centric warfare simulation. It is also used in R&D labs for protocol development and new technology testing. Many PhD research papers are published by utilizing this tool. Netsim also has an academic version to be used in network labs of undergraduate curriculum and advanced network labs of graduate courses like in electronics, computer science, and other related domains. So, providing a holistic view of Netsim, users will be designing the network and configure it in a GUI interface, that is a graphical user interface, which will be then simulated by Netsim engine, and then it will provide multiple metrics regarding the performance of the simulated network. So as you can see, the user is not required to write any script or code while designing or configuring the network scenario. It is simple drag and drop the icons. Now, one striking feature of Netsim is this Netsim engine itself. As you can see, it is utilizing a virtual network stack, which actually copies the real-world TCP/IP stack. And hence, it makes it very easy for any user to edit the protocol and also get fairly accurate results. Moreover, users can also perform research on cross-layer protocols like Leech. Now, Netsim is divided into components or let's say libraries. So the standard version users can make a selective choice while using Netsim. This is the list of the contents of each libraries and their corresponding IEEE or IETF standards referred during implementation. For illustration, let's take component 1. So component 1 consists of protocols implemented in WAN, local area network, then wireless LAN, and the IEEE standards, as you can see, is mainly IEEE 802.3, IEEE 802.11, AB, GN, AC, and various IETF standards. Similarly, component 2 consists of network based on legacy protocols. Component 3 consists of BGP network. Component 4 consists of mobile ad hoc network and WiMAX. Cellular technologies like GSM, CDMA are present in component 5. In the same way, component 6 contains wireless sensor networks and personal area networks. Component 7 contains cognitive radio network. Component 8 contains LTE, which is implemented according to 3GPP standard. And finally, component 9 contains military radio, which is provided only to enterprise customers. So in Netsim V8, we have added newer protocols like LTE and revamped old protocols like BGP and cellular networks. Furthermore, new features like dynamic metrics, user interface property view, and new application models like email, HTTP, peer-to-peer have also been added. So now I will divide this demonstration into two sections. The first being explaining how to design and analyze the networks in Netsim, and in the part 2 or the second part, I will show how to edit the protocol source code and then link it with Netsim. So to design a network in cognitive radio, the user needs to select the cognitive radio option, and accordingly environment panel will come along with all the devices in the ribbon. So users can select the device and drop the device accordingly. So you can see here the various devices: wired node, wireless node, CRCPE, switch, router, the access point, the cognitive radio base station, and the primary user or the incumbent. So before showing how to simulate in Netsim, I would like to rather go through the basics of cognitive radio, and then we will correlate it with Netsim. So the cognitive radio networks are implemented based on the IEEE 802.2 wireless regional area network protocol. So what is the objective of cognitive radio, or why cognitive radio? The reason is simple. In the year 2002, these frequencies were allocated as per their use. For example, for Wi-Fi, the 2.4 gigahertz, and for cellular, the respective frequency bands were allocated. So as you can see here, this is the United States frequency allocation diagram. Now, in the year 2002, no unused or extra spectrum was kept for future allocation. Furthermore, the allocated spectrum is soon going to be not enough. For example, let's take the example of mobile data traffic. As you can see here, the Cisco forecast in the year 2014, it is around 2.5 exabytes per month. And it is expected by 2019, it will become 24.3 exabytes per month of overall mobile data traffic. So the spectrum or the channel allocated for mobile data traffic will soon fall short. And this is actually called the spectrum crunch. So spectrum crunch refers to the lack of sufficient wireless frequency spectrum required for the communication among the growing number of consumer devices. Now, after 2002, in the year 2005, a report was published by Shared Spectrum Company and IIT Wireless Interference Lab, and the goal of this paper was to gain a better understanding of the actual utilization of the spectrum and potentially identify the spectrum bands with low occupancy. As per the conclusion of this report, it was shown that most of the bands were not fully utilized. For example, this TV band, as you can see here, from 54 megahertz to at around like 806 to 902 megahertz, it's hardly utilized 25%. Hence, there is a heavy spectrum utilization in unlicensed bands like ISM band. The spectrum utilization in the licensed bands like TV bands or cellular bands is relatively low. Hence, the cognitive radio technology is a promising technology for the efficient utilization of this available spectrum. Another thing is the spectrum hole. So, as I've just now shown, that the spectrum is not utilized all the time. So, the duration during which the spectrum is not utilized, spectrum hole. So, the use of the spectrum hole I will be explaining further. Now, what is actually cognitive radio? So, cognitive radio is a wireless communication system which is, one, aware of the environment and its changes, and two, can adapt its transmission parameters accordingly. So, if I give say in a point format, the first one is the cognitive capability, that is the ability to sense the unused spectrum at a specific time and location. And the second is the reconfigurability, that is the ability to receive and transmit at different frequency bands by reconfiguring its parameters. And as per the IEEE 802.22 standard, cognitive radio can run only between 54 MHz to 862 MHz, that is the TV band frequency. Radio, as I have already told you, it is for inefficient spectrum utilization. So, current wireless networks are regulated by fixed spectrum assignment policy, which I had shown you already. So, cognitive radio network is a new paradigm, and it provides the capability to the users to use a spectrum in an opportunistic manner. So, the cognitive radio is actually a regional area network. So, in the diagram you can see here, so the range of around 30 kilometers is what cognitive radio represents. Cognitive radio consists mainly of two kinds of users. One is primary user and the other one is the secondary users. So, primary users have the license to operate in certain spectrum bands. That is, they are the owners of that license. But secondary users do not have any license band assigned to them. And for primary users, they have their own base station to control the access of the spectrum. Similarly, secondary users have secondary base station, which is a fixed infrastructure having cognitive radio capabilities. So, the 5 layer of this protocol is designed to support system that uses vacant TV channels, as already said before, 54 MHz to 862 MHz, and it provides wireless communication access over distance up to a radius of 30 kilometers. In addition, 5 specification is based on actually OFDMA, that is the orthogonal frequency division multiple access. So, speaking of all the device and the components, let me show you it in Netsim. So, for the base station, user needs to collect the base station, and for the secondary devices, we have the CRCPE, that is cognitive radio customer premise equipment. So, users can just click and drop it on the environment, and to link them, we need to use a wireless link. Now, this is the secondary users. For the primary users, we have the incumbent. You can also link them. In Netsim, actually this base station is both the primary base station and the secondary base station. Okay? And if the user wants to create a wired backbone, they can also create it. So it's really easy, just click and drop. So this now have created a network, a simple network, and you can see the devices. These are the secondary devices, the primary devices, and this is the wired backbone network. So now the functionalities of a cognitive radio network. So it mainly has 4 functionalities, and it is actually a cognitive radio cycle. So the first one is the spectrum sensing. So a cognitive radio user must sense or must have the ability to sense the unused spectrum at any time and location. Then comes the spectrum management. So after sensing, if the spectrum is available and as per the internal and external policies, it is allowed to use the channel, then only the secondary user can use the channel. So you can see here that as per the external internal policies and the spectrum available, allocation of channel depends. Then comes spectrum mobility. So let's say the secondary user is using the channel of the primary user, the licensed channel. Then in case if the primary user returns or if there is any presence of primary user, the secondary user has to stop using that channel and move to some next best available spectrum band. And the fourth one is the spectrum sharing. So if there are multiple secondary users, then the CR network has to provide a optimal spectrum allocation method among them. So this is the cognitive radio cycle. So you can see here, first the the secondary user will be performing the spectrum sensing to detect the unused spectrum. Then in case if the primary user returns, the spectrum, as per the spectrum mobility, the secondary device has to stop transmitting and search for another free unused spectrum. And in case while using the channel, as per the spectrum decision, it has to capture the best available spectrum, and then if multiple secondary users are there, it has to share the spectrum among the multiple secondary users. And as usual, it will go on in a cyclic manner. So before going into the superframe structure, let me show you in Netsim. So after creating the network, I need to select or set the application flow or the data flow. So let's say this CRCPE secondary user will transmit a data packets to CRCPC or this secondary user. So all I need to do is 2 and 3 are the node IDs, so I'll set it from 2 to 3, and CBR application. Users can further change the application type, let's say custom, email, HTTP, video, voice, and select the application type he or she wants. So I'm taking the standard CBR. Users can also specify the packet size, the inter-arrival time of the data which will be transmitted from one source to the next destination, and they can also add multiple applications. Okay. Fine. So I'll run simulation. So after simulation, users will be getting the performance metrics, which will be specifying the performance of this whole network. So the network metrics, it will allow users to view the values of the metrics obtained based on the overall network, the total simulation time, the total number of packets transmitted. Then the link metrics displays the values of the metrics pertaining to each link. Like for each link, what is the amount of number of packets transmitted, number of packets errored or collided, and more. Then in queue metrics, it will display the values of the queues for the devices containing buffer like routers, access points. And then comes the protocol based metrics. So the protocol based metrics, it will be displaying it will actually depend upon the network simulated. So here TCP is implemented. So you can see the TCP based metrics. So you can see the connections created, the number of segments transmitted, how many segments are retransmitted or fast transmitted, then the active opens, and then the IP based metrics, and in the IP forwarding tables for each of the devices. And as we have around 4 routers, so before the packet is transmitted, a routing table will be created or generated. So for each router, users can see the routing table. And then we have the ARP metrics, ARP table. Now for the application which was running, we are running a single application. Hence users can see the number of packets transmitted and received, and accordingly the throughput and the average delay of all the packets. Now metrics specifically for cognitive radio, users can see the CR base station metrics, the CRCP, that's the secondary device metrics, how many superframe control headers, frame control headers received. This I'll be saying a little later regarding superframe and frame control headers. Then the primary user metrics, that is the CR incumbent metrics. So how long it was operational, how long it was idle, what was the interference time, and which frequency it is using. And then the CR channel metrics. So this frequency, the spectrum 54 to 60 megahertz frequency, how long was it utilized by the secondary user. And other than this performance metrics, user can also see the packet animation. So this is how it is showing the flow of the packets in the network. Now a blue packet specifies a controlled packet. If there is any green colored packet, that means it specifies a flow of data packet, and any red colored packet indicates collided or error packet. So packet animation enables user to watch the traffic flow through the network, and it aids in in-depth visualization and analysis. And unlike other network simulators which only show the transmission of the packets, Netsim goes a step further and it displays some basic packet information like packet ID, the type of packet, and whether it is successful or not. So about cognitive radio, now in cognitive radio, so every 160 milliseconds is divided into super frames, and each super frame contains around 16 frames of 10 milliseconds each. Now before transmitting a super frame, there is a super frame preamble, and for each frame there is a frame preamble. It is mainly used for synchronizing. And the first control packet which is transmitted by a super frame is the super frame control header. So it contains the base station MAC address and also the schedule for the quiet periods. And this information is provided to all the secondary users. Hence, as at the beginning of every super frame, the base station will transmit this preamble and super frame control header. Now let's go into each of these frames. So as said, every super frame will contain 6 frames. So now again, every frame will be having 2 parts. One is downstream subframe and the other one is the upstream subframe. So whenever information or data is transmitted from the base station to the secondary device, it is actually the downstream subframe. That operation is performed during this time. And whenever an information or data is transmitted from the secondary device to the base station, it is performed in the upstream subframe. So you can see here, initially starts with downstream subframe. So after the superframe control header, frame control header is transmitted. And then DS map, US map, UCD, DCD. So just a line about these packets. DS map and US map are broadcast messages, and they specify the resource allocation in the downstream and upstream subframes. So for these subframes, while the DCD and UCD, they are transmitted by the base station at periodic intervals to define the characteristics of the downstream and the upstream physical channels. So let us go back. So you can see first the superframe control header was transmitted, and then the frame control header, and then you can see DS map, then US map, then DCD, UCD, then DCD, and if there is no data to transmit, that is which you can see here, if there is no data to transmit, that is this whole part is empty. And if there is no data or information to transmit to the base station by the secondary user, that means this part is also empty. So it will go to the next frame. So here you can see the next frame control header is being transmitted. Then the UCD, DCD, and again as there is no data to transmit, it is transmitting the next frame. So it will continuously go on until and unless a data is generated in the secondary user and is transmitted. So as you can see here, the secondary user is utilizing TCP and has a packet to transmit. So it is first creating sending a TCP sync packet to create the three-way TCP handshake. Now you can see the TCP sync packet is being transmitted to the secondary user. And before, if I show you here, you can see the bandwidth request slot. So the secondary user needs to request for before using the upstream, before sending data to the base station, the secondary user needs to send the bandwidth request. And then in the next frame, it will be transmitting the data. So you can see here now TCP sync will be transmitted. And so on. And in this way, communication is occurring in the cognitive radio. Now, this performance metrics and the packet animation, these two features are available both in standard and academic version. And these two features are enough for students of undergraduate level to understand about cognitive radio. But if any researcher is working on cognitive radio and needs to edit the protocol source code or analyze the network in depth, these two are not enough. So we have provided some more analysis features. So we have the packet trace, the event trace, and the dynamic metrics. So the purpose of packet trace is that it will log a set of chosen parameters for every packet as it flows through the network, such as the arrival time, the queuing time, the departure time, payload, overhead, errors, collisions, and etc. The event trace It records every single event along with the associated information such as timestamp, event ID, event type, based on the protocol. And dynamic metrics, it allows the user to monitor the value of a parameter over simulation time. So users will be getting a graph which will indicate the throughput through a link or the throughput of an application with respect to time. So if I simulate now, so as said, now I'll be showing you the packet trace. So for each packet, the related information is stored in this file. So you can see here for the packet, like initially OSPF hello packet is transmitted. That is for the OSPF routing protocol. So you can see the source ID, destination ID, the transmitter receiver ID, and along with it, at what time did the packet leave the reach the protocol layers like application layer, transport layer, network layer, and then the size of the packets. And you can easily notice the packets are slowly increasing in size with the respective layers. That is, the headers are getting added, and whether the packet is successful or not. And these are TCP based properties like the local address, foreign address, congestion window, sequence number. So if I scroll down, yes, if I scroll down, you can see here the local, that is the sender address with the port, the receiver address with the port, the application layer, the congestion window size, whether the TCP is established or not, and all the details. Furthermore, being a CSV file, users need not search the whole file. So let's see. There are around like 66,000 rows. So to further assist the user, they can perform filtering of this information. That is, it's an Excel feature. Let's say I want to know all the packets which are transmitted by, let's say, base station 1. So by filtering, I can easily see the specific packets which are transmitted by the base station 1. I did not go through the routing packets or the backbone network packets. Now the next is the event trace. So as said before, event trace will log all the events and the respective information. So you can see here that the routing protocol is running in the application layer in the router, so OSPF. Then the base station has transmitted the SCH packet, and simultaneously the OSPF hello packet events are also getting executed for creating the routing table. And then you can see here the super frame control header, the frame control headers, the DS map, US map, UCD, DCD. So all the events are logged here, and from which node at what time is noted here. So you can see here that, for example, the MAC in layer events, then the physical out layer, the physical in layer events, and so on. So the two trace files which I have shown, they provide the detailed packet information, and it is really useful for performance validation, statistical analysis, and if the user has edited the code, Debugging can also be performed using this information. Now regarding the dynamic metrics, users will be getting a graph like shown in the screen now, that is the throughput graph for the link 1 and then link 2, 3, then the application graph, and as TCP is running, users can also see the TCP congestion window. So this is all about after the simulation, the results which the user will be getting. Now, this is whatever I have shown you till now is all based on the standard values or the default values. If the user wants to edit the parameters, let's say the primary user parameters, so the user can edit it here. So this defines the frequency in which the primary user is running, how long the primary user is operational, and how long it is non-operational. Then the geographical distance, that is, for example, here keep out distance is 100 meters. So the influence of the primary user will be along the radius of 100 meters. So these are all the settings for the primary user. And for the secondary users, the researcher can also specify the range of frequency it will be scanning to find the channel, free channel, the channel bandwidth as per the protocol 6, 7, and 8, the coding rate, modulation rate, and so on. The interface quiet period, cycle length, bitmap. And users can also edit the values like the false alarm probability, the sensing period, intervals, the candidate channel trust, the way before channel time. So all these values are configurable. So as per the standard, the channels are classified into some categories. So the first one is the protected one. So when a channel is classified as protected, it means there is some primary user which is running on this channel. Then the operating classification is given to those channels which are presently being used by the secondary users or by another secondary user. Backup channels are those channels which are ready and can be used by secondary users whenever required. Candidate channels are those channels which are like recently been unused and they can become a backup channel. So there are actually some criteria to fulfill before the candidate channel becomes a backup channel. And then there are channels like disallowed channels which cannot be used by the secondary users, as for like some local regulatory or some external or internal policies. And unclassified channels are those which are not sensed by the secondary users. So I have shown you the academic and the standard version analysis and some exclusive analysis features which are present only in standard version. Now, so in the second part of this demonstration, I will be showing you how to edit the network protocol source code. That is, in this case, I'll be showing you the cognitive radio protocol source code editing and how easy it is to link it with Netsim. So Netsim allows the user to edit the protocol source code, and these C source codes are provided with the tool. So users can also use third-party IDE like Visual Studio 2010 to debug the protocol codes. So as you can see here, each of the protocols like AODV, ARP, ATM, cellular, cognitive radio, so all the protocols are kept in a project manner in Visual Studio. So user can go easily and check the protocol code. So let's see if I go to DSR. You can go and check the DSR code. So they are implemented as per the IEEE or IETF standard. So you can see the DSR packet implemented as shown in the standard. So if the user wants to edit the packet headers or modify them, they can easily do it in the code. So what I will be doing now is to show you the development side. I will be editing a part of the code. That is the cognitive radio protocol source code. I will edit it and I'll show you how to link it. So what I've done is in the init function. The purpose of this init function is before the simulation starts or before this protocol is executed, the init function will run and it will initialize this protocol. So during the initialization, a hello world with lot of stars will be printed in the Netsim console, and unless I send any character or press any button, it will not proceed. So this is the modification I have done in the code. So for development, there are mainly 3 steps. Step 1 is the editing of the protocol, which I have done just now. Step 2 is to create the DLL. So in order to create a DLL in Visual Studio, it's very easy. Just right click, build or rebuild. And you can see here, so build succeeded. So the step 3 is copy this newly created DLL file and paste it in the bin folder. So now Netsim will be reading this modified code. So let me go to Netsim and I'll run simulation. So as per my modification, you can see here now that in the console window, the hello world with lot of stars is getting printed. So the steps for linking your modified code is really easy. Now, in order to reduce the time and effort of protocol developers, Netsim also provides multiple APIs which can be reused to perform activities like packet creation, deletion, IP address comparison, and many more. Netsim also provides a manual in the help section to assist developers while writing or editing the source code. So Netsim is catering to hundreds of customers worldwide, both from academic and research domain. From academic domain, we have some of the top tier universities using Netsim. We are also assisting defense labs and enterprises in the network research and implementation. So to show some of the cognitive radio features in Netsim, what I will do is, I will be providing the primary user the frequencies from 54 to 60 megahertz and an operational time of 10 seconds with no interval. That is, the primary user will be continuously using the frequency 54 to 60 megahertz. And for the secondary users, I will be allocating around 54 to 90 megahertz. So the secondary users can now scan all the channels between 54 to 90 megahertz. So now you can notice in the CR channel matrix, so the 54 to 60 megahertz, it is primarily being used by the primary user. So initially the secondary user tried to use it, but it being seen that it's being used, it will try to hop to other frequency channels, and hence, as you can see here, it is utilizing 72 to 78 megahertz for some time, then it's going to 78 to 84 megahertz, and so on. And you can also see the performance affecting the application throughput. So in this manner, a researcher or the user can perform various research like spectrum sensing, or this channel allocation, or let's say this spectrum allocation, and they can also modify the logic or the code, the protocol source code in Netsim, and analyze the performance. So this is all I have to show, and if you have any queries, you may ask now.
Your mics are now unmuted. You can ask any query from us, or you can write us also. Hello.
Hello.
Yes.
Can you hear me?
Yes, we can hear you.
Okay. Sir, I want to ask you that can we convert mobile ad hoc network into CRN? Hello.
So once again, you want to convert
mobile ad hoc networks into cognitive radio networks?
Mobile ad hoc networks into cognitive radio networks.
You want to integrate these
So
two
cognitive radio.
Yes, integrating.
Yeah.
Okay. So actually,
integrate these two.
So first of all, cognitive radio network is an infrastructure-based network, okay, and mobile ad hoc network is
Okay.
an ad hoc network. So
Right,
what you can do is like this cognitive capability that you can put it in MANET, mobile ad hoc network devices.
Yeah, that's what I am asking. How can we do that?
Actually, it's a research still going on. There are various ways. One of them which I know is like hello, yes. One of them which I know is like implementing cognitive capabilities in wireless sensor network, which is also ad hoc network. So you can check the research papers which are presently going on. They can be done, but I mean, research is still going on in this domain.
And yes, sir. And second question is that how much percentage of researchers use Netsim? Because most of the researchers use LS 2.34 or 3.
Exactly, correct, sir. So last year, I think around 35 to 45 research papers were published using Netsim.
Okay, around the world.
Yes.
Okay, okay. Thank you very much.
Yeah, Major, does Netsim support Windows 8?
Yes, Netsim will support all these things. I mean, from Windows 7 onward, it will support everything.
Okay, okay. And ma'am is asking about comparison between Colnet and Netsim. Please elaborate about this.
Okay, it's like Colnet is our competitor. First of all, there is a huge price difference, which I actually don't know. You have to ask them that. And moreover, Colnet does not have IoT. In the next version of Netsim, we will be adding Internet of Things IoT into Netsim. Also, Colnet does not have cognitive radio. And the creation of I'll tell you one thing, in Colnet, they'll only have one device and you have to configure the device accordingly, like as a router or as a sensor. But in Netsim, we have separate devices, which makes it very easier to configure the network. And there are various differences in the licensing also. So the licensing we provide is perpetual, that is lifetime. But as much as I came to know, Colnet is now yearly licensed. So every year you have to buy Colnet. But Netsim you buy every month and you can use it forever. And also Netsim is floating point license. So you can, yes. Hello.
There is
Hello, am I audible?
yeah, you are audible. One more query, Major. What are the projects we can give to students in cognitive radio?
Your voice is not clear.
What are the various projects we can give to student under cognitive radio?
Okay, for the students, they can are you asking about experiments?
She's saying about projects, type of projects, sort of experiment.
First of all, if they want to learn about cognitive radio, they can go to an experiment manual. We have some experiments like the spectrum sensing, the spectrum hopping. I can show you, like the operational behavior of the primary user affecting the throughput of the cognitive radio secondary users, and how the allocation of frequency spectrum to the primary and the secondary user, and how it is affecting the throughput. So these are some of the experiments which are already done. Also, if they want to do some research projects like MTech, they can do like channel notching, sub-channels, and like it depends upon the research they want to implement. What we usually specify to the researcher is that if provide us the research paper, let's say if this is cognitive radio, then we will analyze accordingly, and then we get back like how much is possible and how to modify the code, which part of the code to modify to implement this, and so on.
Hello, sir.
Yeah, hello.
Hello, sir.
Yes, hello.
Hello.
Yeah, hello.
Good morning. Good afternoon. Good afternoon, sir.
Good afternoon, sir.
Good afternoon.
Session was sir good. My question is, mobile data uploading how can mobile data uploading can be implemented using Netsim?
Once again, your question, sir.
How mobile data uploading can be implemented using Netsim?
Mobile data uploading.
Uploading, yes.
I am using
one simulator for mobile data uploading. That's so how I can that can be implemented in Netsim.
Mobile data uploading. Just a minute, sir. Can you please tell me something about mobile data uploading? I am not aware of this. I mean,
sir, it is related to cognitive radio. Hello.
Sorry.
Sorry, query is related to cognitive radio or any other experiment?
Netsim.
It is okay, but mobile data uploading, can you please tell me the scenario or the network?
In which technology you are using
What you are
mobile
actually
data uploading?
using?
In cognitive radio, wireless sensor network, in which?
Or MANET or Wi-Fi, LTE?
We use one simulator, opportunities network environment simulator, for checking the routing protocols, epidemic routing, probabilistic routing, expert routing, all these things.
Okay, so I'll look into it. I'm actually not getting your question now. I may not be answer
Okay,
at this moment, but I'll look into this and I may give you the answer later.
Okay, thank you, sir.
Hello.
Any other queries?
Hello.
Yes.
Hello.
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 If you have any questions, you may ask.
Yes. Sir, I just wanted to know that how AODV can be used with IPv4.
How AODV can be used with IPv4?
Yes.
Um,
Actually, we are doing it with simulator, but how does it our routing protocol gets integrated in the real world?
how the routing protocol is integrated in the real world? Actually, I wouldn't be the right person to speak about this because I will tell you honestly, every company, let's say Cisco or Juniper, has their own implementation ways. So if you want to know the implementation of the way how Cisco has implemented, you have to ask a Cisco guy. And if you want to know how it is implemented by Juniper networks, you have to ask a Juniper guy. So it is different for each one.
For AODV, yes. AODV's implementation is different in different for different countries. For different companies.
I'll tell you the way it is implemented in real world. I can tell you the protocols and everything, but whenever it goes to real world implementation, honestly saying, all these standards are not followed. I mean, up to a certain extent, yes, but when implementing in real world, they have to make some modification, and this is where the proprietary part comes.
Okay.
I think the respective person or the hardware, the person who creates, they can answer this question better for the real world implementation.
Right. And sir, we will get e-certificate or hard copy of the certificate?
I think Mr. Shravan can answer that better. Hello, Shravan. You just ask this query to Mr. Shravan or email him. We'll give you the answer accordingly.
Okay. Thank you.
Teacher, one faculty is having Netsim version 2. So can it be installed on game? They are having some installation problem.
Once again, Shravan, I cannot hear you.
They are having Netsim version 2.
Okay.
So they are having some installation problem. Can it be resolved?
Actually, Netsim version 2 is very, very old. I think, just ask ma'am, when was it bought? I think it's 2007 or 8. Because it's a very old version. I mean, I don't think it will run above XP. At that time, only XP Windows was there. So actually, like, I mean, okay, let the professor support@tedcost.com. Shravan?
Yeah, I'll send them the email address.
Send them, and accordingly we'll see to it.
Yeah.
is one query, Nirjan. Hello?
Hello?
Nirjan, can you hear me?
Yes.
Yeah, there is one query that the secondary users are allowed to use the unused channel of primary users. So is it allowed as per try, and how it is benefit to the service provider?
Service provider means which one? Primary user or the secondary user provider? I mean,
They're saying that secondary user use the unused channel in cognitive radio, na? So they are saying that is it allowed as per
correct.
try regulation, and is it beneficial for the service?
As much as I know, cognitive radio is still work is going on. I mean, real world implementation is not there. Still in US, that KT radio company is working on it. And in India, cognitive radio devices have come recently. This, I think, last year 2015. But the public use is not yet being done. But still, it is a hot research domain. Work is still going on to improve it.
Nah.
This is the news I have got till now. And as much as I know, like, that's it.
Apa kena? Apa kena? Nah, ini ya. Lama-lama juga. Terus tadi. Review kan deh, Bang.
Any other queries?
No, sir.
Okay. Okay, if there is no query, we should now end this presentation. Thank you all for joining. You can mail us your queries if you have any
Thank you,
query in
sir.
future. You can send us your query on our
Thank you,
mail.
sir.
Okay. Thank you.
Thank you, sir. Thank you.